We talk a lot about building software and infrastructure and the people who make it all work. Today, we're going to cover an oddly persistent issue in the internet age, the oft-dreaded launch day. Whether it's the rollout of a new major healthcare platform for the whole country to use, or when a superstar's concert tickets go on sale, there's a team of engineers with their fingers crossed that everything's going to go smoothly and everyone will be able to at least access the system properly. The players and game developers in the audience are keenly aware of just how well, or how terribly, things can go wrong. With several launches a year that run the gamut, we turn to the games industry to help us find out, why is launch day so difficult to get right? And why aren't companies better prepared to handle the problems they know are coming?
This is Compiler, an original podcast from Red Hat.
We're your hosts.
I'm Brent Simoneau.
And I'm Angela Andrews.
We go beyond the buzzwords and the jargon to simplify tech topics.
Today, we hear about why it's so hard to launch multi-user software.
Producers Johan Philippine and Kim Huang are here to share what's at the end of the Ethernet road.
Our first guest is Stephen Gordon. He's a strategic accounts manager for public sector clients here at Red Hat. More specifically, he's helping the armed forces stand up defense training simulations. And his experience working with 343 Industries, the studio behind the Halo franchise, was a big help. He clued us into some of the challenges multiplayer games face.
There's typically, when you launch multiplayer services games, there's a couple of different problems that you're trying to solve for, regardless of the size of your studio. You're trying to reach players globally, right? So reach. Spikes are a problem.
So we've got two things to start with, right? You've got reach and spikes.
Reach and spikes.
Reach is all about being able to have players to connect from all over the world to your game, right? Depending on where your servers are, depending on how many you have, that can affect who can connect and how much latency they experience. Spikes refer to large numbers of players trying to connect at the same time. And as fast as computers are, there are limits to traffic and loads.
Traditionally, without the cloud or without kind of environments digitally that can handle seasonality, additional players coming onto your game, like, say, Minecraft, so all of a sudden 10,000 new users show up. I've got to handle the spikes. I handle the fast-growing number of players.
We'll get into the technical aspects of that a little bit later in the episode, but I wanted to introduce it here because it's a concept that all multiplayer games face, seasonality. You're not always going to have the same number of users connecting to your games. Excitement and novelty often lead to these spikes, the most common of which being on launch day.
That makes sense.
Everyone wants to try out the game when it first comes out. And as time goes on and the novelty wears off, so does the population trying to connect. There's also a day-night cycle to consider when traffic is highest, and then dips probably a little bit too long after a reasonable bedtime, and then picks up the next day. Then when a big update or a content drop or some expansion hits, you get that spike of users again who want to try out the new content.
Mm-hmm.
Now, on top of connecting to and running the actual game, there's a host of other secondary services that go along with these games, and they present their own challenges.
And then there's the data element, right? There's scale stored around player data globally. There's leaderboards. Now there's more monetization of games and sponsored game players.
Help me out here, Johan. What does the infrastructure look like for what he's talking about?
Well, it's pretty complex. There are three basic parts to running a multiplayer game. The first thing that players are going to encounter is the matchmaker. Think of it as like a waiting room where you first connect to the online service, and then that matchmaker determines, okay, who am I going to connect into a game together, right? Mm-hmm. Based on skill, who's going to be playing against each other, and then what server are they going to go to. You've got the game server itself, which is, okay, now that we've got our players, we're going to spin up a server so that they can play this game. And then that's going to run all the different elements of the game. And then you've got the netcode, which is the infrastructure that connects the players and the matchmaker to the game servers itself. And that is there to make sure that everyone is having a smooth experience, that latency is low, and that everyone is able to stay connected to the game.
Okay.
Stephen gave us a little bit of more details on what that could look like in terms of the actual hardware running games these days.
If I'm hosting a game on a local server, I'm going to have to continue to rack servers and add capacity, scale out, scale up, maybe add memory. By the way, the conventional CPUs are not ideal for rendering what's in modern gaming. So now you're talking about GPUs. GPUs on a server in the cloud are not cheap, right? So I've got to find a way that I can persist and continue to add that capability. But it does solve a scale problem. So prices come down. I have availability to play on cloud-hosted architecture with everything behind it, including large-scale databases, right? Distributed databases, different regions for availability, failover. So you have much more data loss. You have a lot more opportunity for low latency games. Some games require a lot more latency or low latency.
Angela, can you help me out here?
Sure.
I'm not sure I quite understood what Stephen said.
Well, he's talking about making sure the infrastructure is robust enough to handle these types of games.
Mm-hmm.
You need to be able to scale up immediately, right? If you're scaling up.
Those spikes, right?
Right. But we're talking cloud infrastructure. So that usually means scaling out. So instead of having a server, that one server may scale up to 3 or 5. They may scale up in the United States region or a European region, depending on where the users are.
Okay.
Now, he's talking about GPUs because we're talking about graphics processing, and that is very expensive. Expensive on hardware, expensive money-wise. But if you want the best experience for your players, you want to make sure that you have the best infrastructure behind it. So he was talking about a lot of data. So you need databases to be able to scale. They have to be distributed because your customers are distributed. They need to be able to keep track of their scores and where they are in the game and their positioning. And it's a lot of moving pieces. So what he's saying is you can have much more data loss because depending on where you are, if there isn't a really big connection, you may be dropping packets somewhere from where you are to where the servers are. So there's a lot of moving parts. It comes down to how fast your connection is to the internet. We all know we all know that can vary. And then what does the infrastructure look like behind these games and how is it supported? So like you said, launch day is so important and you want to make sure you have to set aside enough infrastructure to make sure that you have the capacity to give your customers what they want. But how do you know? How do you know how many people are going to join you?
Yeah.
That's where the magic comes. How do you decide how much to put up in advance of launch day? So I guess we'll find out more about that. Okay.
Absolutely. Yeah. Just to build on that, because that was all excellent and on point. You really need powerful systems that can handle high volumes, right?
Yeah.
Not only that, but they need to keep latency or lag, or again, the amount of time between a command is sent from a player's computer to the server and then it being recognized and sent back. You need to keep that very, very low, right? These are measured in milliseconds.
Yeah.
When any of the elements that we've been talking about aren't right, the latency, the inability to connect, right? If there's too many people trying to connect to a server and then you get things like long queues to be able to get into the game. If any of those aren't right, it makes for a bad experience and those players are likely to go elsewhere, right?
The stakes are high.
The stakes are really high, especially for launch day, right? Because if you make a big splash and people are able to connect and have a good time, then that'll build and you'll get more and more players and have a successful game. But if it goes the other way, if it's a big colossal failure, that's going to be losses in the long term, right?
Indeed. People have long memories.
Yeah.
Yeah.
Now, Stephen shared just a few of the technologies that are helping with these issues. Our next guest is going to give us some of the technical considerations that can help companies avoid or at least better prepare for the problems that could arise.
Okay, so I spoke with someone who has a little bit of knowledge about the technology needed to scale operations in gaming.
My name's Aaron Moon. I am a senior partner engineer with Unity Game Services, specifically with multiplay. Big long word that basically means I scale video games.
Ooh, he's at Unity.
Mm-hmm.
Yes, Unity. Unity is an engine that a lot of independent game developers use to build their games. Aaron talks a lot about the cultural divide between enterprise IT, so people like us, and the video game industry in general.
Most of the games industry is programming, and they're not really into infrastructure. They digest hosting as a commodity, and so these things weren't just not a focus of theirs. So that was surprising. So I had to bring some of that with me. Shell scripting, a lot of those fun things, working on game servers. Those were skills that I brought and that were kind of born and bred the hard way. Former RHCSA, RHCSE. So, those skills actually did come to bear, and it was very useful.
RHSC.
Yes, RHCSA. That stands for Red Hat Certified Systems Administrator, and RHCE, which stands for Certified Engineer, respectively. Those are the two certifications that Aaron kind of cites as being in his background, and that was part of the experience that he brought to Unity Game Services.
Got it.
So you could say that Aaron brings that kind of experience, that enterprise IT mindset, to work that largely doesn't fit that mold in video game development. But why is that? Aaron says for smaller development studios, the money just isn't there.
From an indie perspective, you've got an ROI per concurrent user that you're trying to preserve, right? You have a budget, what you can spend in infrastructure. So a lot of those solutions that would pass muster in the enterprise realm, they just financially, they're not feasible here yet.
That is so true. You want high availability, you want redundancy, you want fault tolerance, you want to be in multiple availability zones. Every word I just said costs more money.
Mm-hmm.
Right, yeah. Okay.
If you're talking about spending money and making sure that the concurrent user can match up to your infrastructure, sometimes you're not going to get the infrastructure that you may think your game deserves, because all of this is super expensive.
Yes. It also requires people to maintain, right? If I'm not mistaken.
Indeed.
So
Indeed.
you have a lot of game developer teams that are only 3, 4, or 5 people that, they're trying to scale up and they're trying to have that high availability, but they don't have the money or the people in order to support that at first, at least. But studios who have to, or want to rather, satisfy large game publishers and player demand, they want to expand and be more successful and be larger, have that money to kind of, hire more people and build out their operations. They have to enter a world where it looks a lot like where we work every day, the enterprise level. There are so many things to consider. How is the game going to make money? That means in-game purchases or a marketplace where people could buy, for example, cosmetics for their characters. Will there be expansions or other downloadable content? All of that involves programming, data, servers, product design, stacks, platform integration, and a whole lot of planning.
That's a lot.
Yes.
That is.
As games are launched, it sounds like some developers suffer from what I like to call the curse of success. I'll let Aaron explain.
The infrastructure is really also indicative on the scale. We speak with studios out there, small ones that have blown up. I've seen situations where they have their own small scaling infrastructure and then they blast up into the millions, right? Kind of that lottery ticket scenario. And so they actually have to change in step, while their game is launching and blowing up. So I would say, if you're doing the kind of session-based, a lot of the infrastructure you want to set up is to be able to quickly scale in multiple regions and locations, no notice. You're going to rely on the cloud in so many ways. Now, if you can mitigate the cost and have bare metal infrastructure staged there, maybe you have marketing data that tells you, You've got this many people signed up for pre-launch, so it kind of guides your hand. That'll help you set up the server infrastructure.
Now, Angela, earlier in the episode, you said something along these lines. How do you accurately predict how many people are going to be there on day one? How do you know how many users you're going to have on a launch? One of the metrics that people use in the gaming industry is pre-orders or pre-launch signups. There are a number of other types of metrics and things that they use. Beta, a lot of games will open for beta to see kind of what the interest is and kind of measure how many people signed into sessions, how many people were able to get into sessions. It's it serves two purposes. It's kind of like a stress test for the game that you've built. And then on top of that, you also can gauge interest to see how many people will sign in on that day one.
So that's interesting because you want to see, well, how have we been marketing and who's been interested so far? So at the very least, you have to account for that. And you want to make sure that your infrastructure in the beginning, before any real scaling happens, is already in place to match what you think your capacity will be. But then right after that, you have to make sure that, if there's this lottery ticket scenario that Aaron's talking about, this could blow up. And how do you make sure you have the right infrastructure and scalability and automation and availability in place? If this game goes global, how do you make your customer in Philadelphia, Pennsylvania have an amazing experience? And how do you have your customer in, Paris? How do you make sure everyone's getting what they need? And you're right, the curse of success, if it blows up past what you've allotted, someone might be upset.
Exactly.
Someone's going to be upset.
What does that actually, because I've never, experienced this before. What actually happens when your game blows up?
Let's say the indie game developer and they've built a new game. Maybe their intention is to, have this game and publish this game on their own and kind of continue on as an indie developer. Or maybe they want to get noticed by a larger gaming publisher, which, you have larger, Microsoft is a big game publisher. If you're aware of the market, you know that they have a lot of different studios that they work with to make the games that they release. But in order to kind of get their attention, you have to have a pretty successful launch, right?
Yeah.
So let's say this new game launches and the server infrastructure is built and tested, and we'll get to that later, testing, but it's built and tested for about 50,000 concurrent players. And the sessions are very small. Let's say each session is 3 to 4 players or something like that.
Yeah.
But the sessions go very quick. So maybe a battle royale style game. But for whatever reason, the game goes viral. And overnight, you have hundreds of thousands of players trying to access the game. But they can't get into a session because there's too many people in the lobby. So they go to social media and let the devs know, let everybody who will listen, let them know that there's a problem with the game. They can't get in, they can't play. It's day one. They want to play their game. They spent their money. Media picks up the story, and now you have a situation where a developer is, they have a bad reputation or a bad game launch. Now the developer has to work hard to scale up their game. That typically involves hybrid cloud infrastructure nowadays, which costs money and time, like we talked about earlier.
Yeah.
And basically, they have to hope that people come back to improve that long tail player number. So it's post-launch, you're going into the weeks and months following, and you're trying to entice people to come back to your game. Maybe you're doing some more marketing. Maybe you're doing a lot of community management. That's where community managers kind of come in and they go, hey, the player community, we want you to come back. We want you to try this new expansion pack or these new downloadables. We want you to, come in and explore what we did to fix all the issues we had before. And the positive outcome is that players come back, they enjoy the experience, and sometimes that can lead to more projects being greenlit, especially if they have an agreement with a larger publisher, and people get to work on new games.
I imagine that's not always the case, though, right?
The negative outcome is that players, don't come back, and those long tail numbers don't go up. The game pretty much flops, and game publishers lose faith in that, and new projects don't get greenlit. And if new projects don't get approved, the studio has to go out of business.
What I'm thinking about is that there's probably some kind of playbook or some kind
That's
of...
what I was just thinking. Like,
Yeah.
what's the formula? Is there a formula
Yeah, some kind of formula
that we could follow?
tried and tested
Yeah.
that we can follow. At the same time, though, I'm thinking about how like each one of these cases is going to be unique. So there's a playbook, but then you're probably going to have to adapt and be really nimble and, you know?
It's a catch-22. To me, the thing that makes a game enticing is how it sets itself apart. And a lot of that has to do with the actual play experience, right? And that's why you have so many different types of technologies like that stack and the engine and the middleware, the net code, like Johan was talking about earlier. Those things come together and create a unique player experience.
Yeah.
And that's why, according to Aaron at least, no two launches are the same.
Yeah.
This is why testing well and testing often is very vital.
So the most common ones I see are the failure to adequately test their back end, right? The way that you approach that is frequent testing. So in the industry, we like to simulate launch failures. Think of it like the chaos monkey scenario, right? We're going to throw everything at it and watch it catch fire, analyze the ashes, and then, we come back and we get ready for launch.
Wait, that's that's real?
That's a real thing.
That's a real thing. You deliberately kind of crash your servers. You deliberately try to break what you've built just to see, if it can stand the fire, if it can handle the load.
We have more on this in season 2 of Command Line Heroes.
Oh.
If you want to hear more about the Chaos Monkey and the
And Chaos Monkey is the official name.
yeah,
It's
a real tool.
Yes.
Huh.
But, what you were talking about earlier, Brent, Angela, about the formula, there is no real formula here. It just depends on trying to predict. And sometimes you can't predict popularity. You can't predict success in this case. And therefore, you can't predict that your servers will be able to handle everything.
That is not the answer I want, Kim.
Me either.
No, but it's true.
But I guess that's the reality we have to live with.
Yeah.
That's right.
I mean, it feels like if you've done all the things properly, you've done your due diligence, you've done your QA testing, you've done your chaos monkey testing, and you discover things that are broken, you fix them, you built in that resiliency, and the game comes, the players come, and it's still not enough. What do you do next? You've done everything you could possibly do, and it still has the risk of not being successful. That's a lot of pressure.
It is, but if you think about it, it's not very different than what happens in the enterprise, right? What do? You go to your users and keep open a clear line of communication with them and be honest.
Yeah.
You say,
That's true.
we're working to resolve the issues on the back end. We're working and doing the best that we can with the resources that we have. And we hope this experience will not put you off on coming back or, using our platforms and using our products because, we're actively trying to adjust and improve and adapt.
And is this just because, people are unpredictable? You don't really know until you get lots of people, real people in there playing?
Yes, that's exactly it. And Aaron can speak a lot better to this than I can.
You can test all you want, but until you put real players at mass in your game, you don't really understand how they're going to interact. You don't understand what kind of load profile that is.
And this is a persistent problem even for game studios who have a lot of experience launching their games, right?
Absolutely.
We've seen some AAA games that on launch day, even though they've had big games launched in the past, because each game is new and different, it requires a slightly different set of infrastructure. And because of that, you're going to have some interactions that you're not prepared for.
Right. Maybe this time around, you're launching a very large, cosmetics based aspect of your game, and that introduces a whole new level of physics and things with your characters interacting that maybe on a previous launch you didn't have to worry about, but now you do. You're introducing new features, and when you introduce new features, you kind of have to figure out how that's going to affect the way that all the rest of your infrastructure works together.
I want to come back to something we were talking about earlier, which is the cost of all of this.
Yeah.
I was just thinking about how it's probably just as important to be able to scale down
Yes.
than it is to be able to scale up.
Yes.
Scalability in and of itself is a powerful feature of the cloud. That's what makes it amazing. The ability to, at the click of a button, you're literally able to scale that infrastructure and everything underneath it as well. Servers, firewalls, regions, load balancers, these things grow and grow. But when the traffic goes down, you cannot keep all this stuff up and running. So your app has to be smart enough and say, okay, our load has gone down. It has been down for whatever threshold you've set. Then it starts to orderly scale things down. And that's what you want. You want that built-in scalability to make sure that, one, yes, you can hit those marks when you need to, but definitely don't leave stuff running
Right.
when you don't. Don't do that.
Yes.
Burning money over there.
Yep. Burning money. That's exactly, actually, I'll bring Aaron back because he says it again. He says this in a way that I feel is pretty powerful.
In hybrid, if I buy a machine for a month and I can host X amount of sessions on it and it's always full, I'm winning because that's probably going to be a lot cheaper than cloud. But if I'm doing the same thing in cloud, 3 times the expense, it's so much more expensive. So unless that thing is only on when it needs to be used and turned off as soon as it doesn't, again, I'm just bleeding out spend. So scaling down is definitely something that needs to happen the right way, because when you're running a live service game, you can't just push the stop button. There's no empty button to kick people out of servers.
That's interesting. And when you're talking about cloud, you're paying for that data, that ingress and egress. Like when people are using that game, every click, all of that costs money.
Yeah.
Like you said, if it's always running, if it's just your system and you don't have to worry about, bandwidth or things like that, when you're in the cloud, everything costs. And having that data get back to your customer and then putting data up there, sometimes there's no ingress cost, but definitely egress cost. Man, you're burning money.
That's
So
right.
Aaron has a point here. You
Yeah.
have to be very frugal and smart about that because you're going to be losing money.
One of the things he was telling us about that inexperienced game studios face is they've scaled up and they've got their cloud instances running. And then when they try to scale down, they've got maybe one of the cloud servers has a game running and they don't want to just cut people off because that's a bad experience.
Yeah.
But in the time that it takes for that one game to finish, it may launch another single session on that server. And so unless you've got the proper load balancing to really offload any games from appearing on that cloud server again, you're coming up with a problem where that one server is being used for a very low amount of population. So it's something that you really need to take into account when trying to figure out how you're going to scale down that cloud footprint.
I want to switch gears and talk a little bit about patching. So if you talk to players, they will always look at you whenever you say day one patch with a mixture of happiness and fear. A day one patch happens when there are issues or other desired changes, maybe not, but related to bugs, that need to be done after a release. It's not a sign of failure necessarily. It's meant to make the playing experience better. But Aaron says proper planning for scale when patching a game is key because it can make or break a studio.
And it also has to be thought of when you're patching, because how do you bleed them from one version to the other? So it's a very long, multifaceted issue, but scaling down is where people really kind of lose, and where we see games when they start to go into long tail numbers, they just simply go out of business if this is not mastered.
So there's multiple issues here
Yes.
that I hear Aaron mentioning. He's talking about the issue of not being able to scale down because all of your players may be spread apart, all these different servers, and you can't remove those resources. Well, that's a problem. But when you're talking about this day one patch where, well, how do you intelligently decide which players are going to get patched and how. How do you roll these patches out? So at some point, every player has the newest version of the software. And again, this is another planning exercise. Like, you have to make sure it's done smart because, again, if a customer has a bad experience anywhere in between, they're going to feel it and you're going to hear it.
So Kim, Johan, Angela, we have been talking a lot today about games, but launch days are a reality for a lot of people outside of gaming. So I'm kind of curious what we can take away from this example and port over into other scenarios or other facets of, our lives.
I'll start.
Yeah.
Planning is key.
Okay.
That's what we're hearing. Planning is so important. Testing is important. Listening is important. Yeah. These are all skills that are totally transferable, even if you're talking about game launches or software launches or concert ticket, first ticket days. Those are things that are synonymous across all of those different use cases.
Yeah.
And when things go wrong, and apparently they will, because it sounds as if like you really can't gauge it. Sometimes things go wrong.
Yeah.
But an effective postmortem, what did you do exceptionally well? Well, why'd you do it so well? How? And then if something goes wrong, well, what went wrong? What needs work? Well, why? And then you figure those things out. And I think having open communication, it doesn't matter the vertical or what you're launching, but those are the things that I think we can kind of take away, that this is how you be remotely successful and this is how you bounce back.
How about you, Johan?
There's a couple things that came out for me, and I'm going to use the game industry as the metaphor here, but the biggest thing is that no two game launches are alike, right? And to best prepare your launch and to best build the infrastructure to support that launch, you really need to keep the type of game that you're running in mind, right? Is it going to be a lot of short sessions that need servers to go up and down in quick succession? Or is it longer sessions like something like a massively multiplayer game where the server stays on for a very long time, right? Those two launches have very different needs. So
Correct.
You keep that type of launch in mind when you plan for that infrastructure. What that leads to is that, this is what Angela was saying, success isn't necessarily in the right kind of tools. It's more about the process of launching the game, right? And you want to make sure that because each launch is different, you are asking the right questions, that you are planning the right way, and that you are testing everything over and over and over again until you get to that launch day.
And Kim, how about you?
Well, I definitely came away from this episode with a better understanding of why software launches are so complicated. There's the extremes of failure and then too much success when, honestly, if a development team is working with like a small budget and the resources are finite, the ideal might be somewhere in between those two things, but there's no way to gauge or predict success or trends or user demand. I think that there's a lot of mind share and a lot of collaboration that can happen between people who work in enterprise IT and people who work in video game development. There's different things that they could learn from each other. And I think that development teams can do a lot of research and planning and exploration of open culture and other kind of use cases and all of the knowledge that people have shared about the process to try to get through a product launch the best way they can. Also, I want to talk a little bit about the Red Hat community of practice because they did help us make this episode a little bit. So for those of you who don't know, Red Hat has a community of practice that is a community of Red Hatters who use open source software to create games. If you stick around for the credits, we can tell you exactly how to find out more and get involved.
So that was the launch day episode. We learned so much about game launch days, but we want to hear about you. What are some of your favorite game launch days? And what did you learn from them? Would you mind tweeting us at Red Hat? We would love to hear about it. Don't forget to use the hashtag #CompilerPodcast. We'd love to hear it.
I have a couple of favorites, but I'm not going to name names. But please feel free to tweet us and name names.
Yes, name names. We would love to know what some of your favorite game launches are so we can keep an eye out for those. Or on the flip side, if you've experienced horrible game day launch days, we want to hear about those too. Come on, share the dirt. Share the dirt with us.
Yep.
And that does it for this episode of Compiler.
Today's episode was produced by Johan Philippine, Kim Wong, and Caroline Craighead.
A big thank you to our guests, Stephen Gordon and Aaron Moon.
Victoria Lawton makes sure our distribution infrastructure can handle the load.
So, Red Hat has its very own gaming community of practice, and they are currently looking for contributors. If you want to learn more or get involved with a launch of your own, visit arcade.redhat.com. That's arcade.redhat.com.
Our audio engineer is Christy Chan. Special thanks to Sean Cole. Our theme song was composed by Mary Anchetta.
Our audio team includes Lee Day, Stephanie Wunderlich, Mike Esser, Nick Burns, Aaron Williamson, Karen Keene, Jared Oates, Rachel Ertel, Devin Pope, Matthias Foundes, Mike Compton, Ocean Matthews, Paige Johnson, and Alex Trabulsi.
If you like today's episode, please follow the show, rate the show, leave a review, share it with someone you know. It really helps because sharing is caring.
All right, we will see you next time.
Later, guys.
Bye.
And gals. Later, folks.
All right, bye.
And see.